We are going to identify a parallelogram in a coordinate plane. Here we have the figure ABCD. It looks like a parallelogram. We know for sure it's a quadrilateral since there are 4 sides, and we need to prove it. And there's really multiple ways to prove it. One way is just to see if AD and BC are the same size and AB and DC are the same size. But I kind of like, and that would be using the distance formula 4 times. I think I would like to prove that 2 of the sides are both parallel and congruent. So I'm going to use AB and CD, the distance formula on both of those, and then I'm going to find the slope of both of those. And I know that if I can prove that a pair of the legs are both congruent and parallel, then that's enough to prove that it's a parallelogram. So these are the 2 formulas I'm going to be using, the distance formula and the slope. And I will be using the AB, these 2 ordered pairs, and the CD to do so. So let's start out with using the distance formula for AB. And I'm going to make the template, because the template makes sure that I don't forget any minuses that's in the problem. All right, so there's my template. It's everything except the x's and y's that need to be replaced. Now for AB, I could name these x1, y1, x2, y2, and then ensure everything goes in the proper spots. So that's 2 and -3 in the x's positions, and for the y's, it's 5 and 3. So I have to add the opposite here. 2 plus 3 is 5. I've got 5 squared. And then 5 minus 3 is 2. I've got 2 squared. So I have 25 plus 4, which is the square root of 29. And I can just leave it like that at this point, because all I need to know is CD going to be the same thing? All right, so CD, I'm going to call this x1, y1, x2, y2. And I'm going to make my template again. So big old square root, 2 sets of parentheses, minuses in the middle, plus in between, and the squares. All right, for the first ones, the x2 and x1, I'm using 0 and 5. And for the second one, for the y's, I'm using 0 and 2. Okay, so -5 squared, make sure you put that in parentheses. Plus -2 squared, I'm going to end up with a negative times negative is a positive, so that's 25 plus 4, which is the square root of 29. Okay, so those are the same. I now know that AB is congruent to CD. They're the same size. They're the same length. All right, now we just need to prove that the slopes of these 2 are the same. I can use the slope formula, but if I have the picture, I'm just going to count it. So the slope of AB, all right, let's just count it. Remember, it's the rise over the run. So I'm counting up 1, 2, I'm rising 2, and I'm running 1, 2, 3, 4, 5 to the right. So that slope is a positive 2/5, 2 over 5. And then let's get the slope of CD. Okay, start at the bottom, rise 1, 2. So the rise is 2, and the run is 1, 2, 3, 4, 5. So that's 2 over 5. So now I know that AB is parallel to CD. And since AB is congruent to CD and parallel to CD, then it must be a parallelogram. So this is a parallelogram.